Hey, welcome back to Rithmetic with Ron. What do we do when we have a decimal and we're asked to turn it into a fraction? Today I'm going to show you how to do that, whether it's just one decimal or a repeating decimal. I hope you enjoy the video. Go ahead and hit subscribe and we'll see you. Let's begin today's lesson with a quick review on place value. So I've got a decimal here, and what we want to remember is that starting to the right of the decimal we have the tenths, the hundredths, the thousandths, the 10,000ths, and we could keep on going, okay? The tenths place can be represented by 10 at the bottom of a fraction, the denominator. And how many tenths do we have? Well, we've got 2. If I look at the 3 is in the hundredths place, which means the denominator is 100, and there are 3 of them. Okay, so using this, what we're going to do is convert decimals into fractions, and we'll start out with a simple one, the decimal 0.5. Okay, let's convert that into a fraction. Well, the 5 is in the tenths place. That has the root 10, and so the denominator in our fraction is going to be 10. For the numerator, we ask, how many of these tenths do we have? Well, we have 5. And so 5 tenths is the fraction equivalent of our decimal. Let's do one that's a little bit more, and we'll do 0.75. How do we read this? I just said 0.75, but you could say 75 what? Well, the hundredths place is the farthest that this decimal goes. So we're going to have 100 in the denominator because tenths comes first and then hundredths, and that's where it stops. And how many hundredths do I have? I have 75. One more example here, 0.164. Okay, so 4 is the place value all the way to the right, and it is the tenths, hundredths, thousandths. Since this decimal goes out to the thousandths, in our fraction, we are going to write 1,000 as the denominator. And how many do we have? We have 164. So the basic pattern that we're seeing is when you see a decimal, you start by figuring out how many place values are at the end. What is the place value of the number all the way to the right? If it's tenths, then you would have a denominator of 10. If it's thousandths, you would have a denominator of 1,000. If I had a decimal 1, 2, 3, 4, 5, tenths, hundredths, thousandths, 10,000ths, 100,000ths, then 100,000 would be the number at the bottom of my fraction because that's the last place value. And then you take the digits that are written to the right of the decimal and you just copy them over. Let's go ahead and try an even longer decimal. How about 18425? 0.18425. We're going to do the same thing and identify the place values, tenths, hundredths, thousandths, 10,000ths, and 100,000ths. If this place value is the 100,000ths, then what we need is a fraction that has 100,000 on the bottom. 100,000. The 100,000ths place value means we need 100,000 as our denominator to convert the decimal to the fraction. Notice that we have 1, 2, 3, 4, 5 place values or digits to the right of the decimal. 1, 2, 3, 4, 5 zeros. And that pattern will hold true. If I had 184, that would be 3 decimal places, and it would be in the thousandths place, and 1,000 has 3 zeros. So that pattern works. However many place values to the right of the decimal is how many zeros you have in the denominator of your equivalent fraction. Then we're going to carry the numbers over, 1, 8, 4, 2, 5. Now this fraction, because these numbers end in 5 and 0, there is something we could do to reduce this to a more simplified fraction. I'm not going to do that in this video, but this value made by these two numbers has the equivalent value of this and would have the same equivalent value as a reduced fraction. What we've seen so far are decimals that don't go on forever. They are truncated. That means they stop. What happens if I have a decimal that just goes on forever and ever and ever? Okay, if I want to convert this to a fraction, there's a little bit of extra work we have to do, and it's got some very minor algebra, but it's kind of clever. And so let's go ahead and take a look at how to handle this. This pattern of 3, 5, 3, 5, 3, 5 goes on forever, out to infinity. And so we can't just count place values and come up with a fraction, because the place values go out forever to infinity, and I would have a fraction with zeros that go out to infinity. That's not really going to work so well. So how can we solve this? What we are going to do is we're going to take this decimal and we're going to say x equals this decimal. X is a variable, and it has an assigned value in this case of this long decimal that goes on forever. Now I have an equation. This is equal to this long decimal. Let's go ahead and multiply both sides by 100. You might ask, why 100? A couple things. First of all, whatever we do to one side of an equation, we have to do to the other. And the second thing is, this decimal has two digits that repeat. And so if I want to move the decimal place, the number of digits that repeat, I have to move it 2 spaces. After 2 spaces, it starts over. And this would be true if you had a single digit that repeated, like 3, 3, 3, 3, 3, 3, 3, or if you had longer digits. If you had 1, 4, 2, 8, 5, 7, and then it repeated, if all of this repeated over, then you would have to multiply by not 100, but you'd have to multiply by 1 with 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. You'd have to multiply both sides of the equation by whatever number will move the decimal point until you have covered one set of repeating decimals. Let's go ahead and erase this, and we'll finish this problem and see how can we do this? How can we turn this into a fraction? If I multiply the left side, I get 100x is equal to, well, what happens on the right? When I multiply by 100, I move the decimal point 2 units, and I'm going to get 35.353535 repeating forever and ever. Now what we're going to do is we are going to subtract x from both sides. X, recall, has a value of this repeating decimal. So if I subtract x from the left-hand side, on this side, I'm going to subtract what x is equal to, which is 0.353535 repeating. X and this decimal have the same value, and if I subtract the same thing from both sides, then my equation is still true. On the left-hand side, 100x minus x is 99x. On the right-hand side, look what happens. 35 minus 0 is 35, and then the decimals all cancel each other out to infinity. Both of these decimals go forever, but because they're the same, when I subtract these, I'm going to get nothing, because everything to the right of the decimal is the same, and when I subtract something from itself, I'm left with nothing. Now that I have 99x equals 35, I can divide both sides by 99, and I get x equals 35 over 99. And so that is the equivalent fraction. If I wanted to turn this decimal, 0.353535 repeating forever, I would have a fraction of 35 over 99. That method is a clever way to handle repeating decimals. Let's go ahead and do one more real quick example with something that's perhaps a little bit easier. Here we're going to use a decimal that only has one number repeating over and over again. Let's use the decimal 0.444 out forever. 0.4 repeating out forever. So again, we're going to say x is equal to that decimal. I only need to move the decimal point one place since it's the same digit that's repeating. So I'm going to multiply both sides of this equation by 10, and I'm going to get 10 times x is 10x equals, if I multiply this decimal by 10, I'm going to move that decimal one unit to the right, and I get 4.444 out forever. Now we're going to subtract x from both sides. But on the right-hand side, we're going to subtract what x is equal to. This decimal has the same value of x in this problem. So I subtract x over here, and on this side, I'm going to subtract the decimal that it's equal to. And what happens is 10x minus x is 9x, and when I take 4 minus 0, I get 4, and all of these decimals are equal, and they're going to cancel out when I subtract them. These decimals are canceling the same way. If I took 1 minus 1 and got 0, I'm taking something and I'm subtracting it from itself. Here's another example, 5 minus 5. You take something and subtract it from itself, you're left with nothing. That's exactly what's happening right here. So I get 4.0. And now I divide both sides by 9, and I get x equals 4 over 9. And if you put 4 over 9 into your calculator, you will get the decimal 0.4 repeating, or 4s forever. So today we saw how to turn a decimal into a fraction. Go ahead and leave me any comments or videos that you want to see in the future. Hit that subscribe button. Thanks again, and we'll see you next time.